Assalamualaikum warahmatullahi wabarakatuh. My name is Jasmine Hazikin binti Abdullah. In my group have 3 members, which is me, Ilya Nasrin binti Safwan, and Yusuf Muhammad Idris. Today we want to present to you about our project. First of all, we will go through the introduction. Pipe network analysis involves the determination of the pipe flow rates and pressure head at the outflow point of the network. The flow rates and pressure must satisfy the continuity and energy equation. This analysis uses 3 methods, which is Hardy-Cross method, Nodal method, and Newton-Raphson method. In our analysis, we use Hardy-Cross method that is known as the head balance or closed loop talk. This method is applicable to systems in which pipe from closed loop. The outflows from the system are generally assumed to occur at the method is based on the continuity equation, which the inflow equal to outflow at the nose. The equation is as shown, but this equation only applied when approximate the discharge at first. Then for the second trial and above, the equation used to determine the value of Q for each pipe in each loop. The equation for the second trial and above is as shown, but also this equation does not apply to the pipe which is shared by 2 loops. If it's shared by 2 loops, you will use the equation. Next, the energy equation in Hardy-Cross method in summation of head loss in closed loop is 0. The equation for that is there. Besides, the relationship between head loss and discharge must be maintained for each pipe and determined using Darcy-Weisbach equation or exponential friction formula Hazen-Williams. But in this project, we use Darcy-Weisbach to determine the flow in each pipe based on equation. Okay, let's see the pipe analysis. 2.1 is the details of each pipe. So we look at loop 1. We have 4 loops, which is loop 1 contain of pipe 1, pipe 2, pipe 3, pipe 4. Loop 2, which contained by pipe 3, pipe 5, pipe 6, and pipe 7. Loop 3, pipe 4, pipe 7, pipe 8, pipe 9, pipe 10. And loop 4 is contained by pipe 10, pipe 11, pipe 12, pipe 13. Okay, now I will tell all of you about the example. We cannot go all of the example, but we go through the some example like 2 or 3 example because we have insufficient time. Okay, look at loop 1, pipe 1. We get 8 inches, 0.2032 meter, 38 meter for length. Friction factor we got 0.001, and the last is from Darcy-Weisbach equation we got 9.0633299. And the second pipe from loop 1 we got 4 inches, 0.1016 meter, 268 meter for length, 0.002 friction factor, and we got from the Darcy-Weisbach equation is 4090.887007. That is one of the method of the every loop, every pipe is as same as what I have said just now, which is use the how many diameter in inches, how many diameter in meter, how many length in meter, how many friction factor, and using the Darcy-Weisbach equation. That's all for details of each pipe. Okay, now we go to 2.2, which is the diagram of the flow and direction of each pipe and loop. First of all, we look at the inlet, which is at J, at point J. It will pass through the other point and will out at Q outlet, which is at A, G, and H, which is 30. All of the things will go in from the point J and will pass through to the A, G, and H. Wherever they go, they will go to A, G, and H only.
My name is Mohammed Idris. I'm here to talk about the calculation of pipe network analysis. In this analysis, we used 2 methods, Darcy and Hardy-Cross method, and there was instruction given to us, and we told to ignore all the minor losses and at least two loops must be in 0.00 value. And also we had instructions as details of each pipe, calculating the diameter and the length. And as we can see here in the first trial, using all of that, we found out in loop 1 0.004 and in loop 2 0.003, and here in second trial 0.007 in loop 1 and loop 2 for second trial was 0.001, negative 0.001. And also we have here example of loop 1 of first trial of the calculation. So we can say also we have here the Q of P3 for pipe. We have in two types of loop, and here we find out it was 0.004.
Assalamualaikum, my name is Ilyana Nasrin binti Safwan. I will explain about the calculation for loop 3 and loop 4. For loop 3, this is the diagram, the area of loop 3, which is have the pipe of P4, P7, P8, P9 until P10. In the loop 3, we have two Q outlet, which is the value is 30 length per second, and after that the diameter, length and friction factor is given, and we need to calculate the value of K, which is the formula is F times L divided by 12.10 times d power of 5. After we get the value of K, we need to assume the value of Q, which is we assume that in P4 37 length per second, P7 30, P8 10, P9 20, and P10 10 length per second. After that, we for the first trial, we include the value of K here and the value of Q that we assume, and then we need to find the value of HF, which is the formula is K times Q power of 2. After that, we need to get the value of N times K times Q power of N minus 1. The value of N is 2, and after that we need to calculate the total of these two formula, and then we can get the total of dq, which is the total of hf might divide by the total of n times k times q power of n minus 1. So we get 0.002333649. And then we continue for the second trial to get the value of q, which we need to plus the q1 plus the q1 here from the first trial, and then back in for P4, P7 and P10, which is the pipe have in two different loop, which is the loop P4. We have also in loop 1 for loop for pipe P7. We have in loop 2, and pipe P10 we have in loop 4. So it will be the different method to get the Q, which is the total of loop here from Q1 need to plus the dQ1, but dQ1 need to minus by the other dQ, from the other loop. So after that we can get the value of Q for the P4, P7 and P10. This is the formula, after that we can get the total of HF and total of n times k times q power of n minus 1. So, and then we get the total. After we get the total, just use this formula, which is the q is minus total of HF divided by n times k times q power of n minus 1, and then we just continue until the value of the q get the 0.000 and the from the final trial, which is fifth trial, we get the 0.000273181. And then for loop 4, the diameter, length and friction factor is given, and here is the area of loop 4, which is have pipe P11, P10, P13 and P4, and start with the Q inlet, which is 19 length per second, and the Q outlet is 13 length per second. And then we need to calculate the value of K. After that, after get the value of K, we assume the value of Q, which is in P10, we assume 0.01, P11 0.05, P12 0.04, and P12, which is anti-clockwise, we assume negative 0.04, and P13 negative 0.04. And then we need to calculate the value of HF and the value of n times k times q power of n minus 1. And then we need to get the total and the value of dq. We get 0.009810325. After that, we continue with the second trial to get the Q2 with the same method, which is to get the Q2, we need to calculate the Q1 plus total of dQ1 from the first trial, and we get the value of Q here. And for P10, we need to use this method, which is the total of Q1 here plus the total of dQ1, but dQ1 need to minus the value of the other dQ1, which is in another loop. And then we continue until the fifth trial, which is the final trial we get for total of dQ5 is negative 0.0000159.276. That's all.
Okay, then the conclusion is the method that we use in this project to analyze the piping network is Hardy-Cross method with Darcy-Weisbach equation to analyze the fluid flow in any network. Besides, this method is the repeating method for determining the flow in pipe network systems, where the input and output are known but the inside flow is unknown. By using this method, firstly, the flow in any junction must equal to the flow out of it. Secondly, the flow in each pipe must satisfy the pipe friction loss for flow in a single pipe. Lastly, the algebra sum of the head losses around any closed loop must be 0. Other than that, application software such as Microsoft Word, Microsoft Excel are being used to solve this task. Even though for the first time use, it is quiet and difficult, and then it was easy. With this task, we learn from our mistake, and in the future, we will improve. Last but not least, the Hardy-Cross method is useful because it relies on only simple mathematics, circumventing the. With this task, we learn from our mistake and in the future we will improve. Last but not least, the Hardy-Cross method is useful because it relies on only simple mathematics, circumventing the need to solve a system from the equation, and the Microsoft Excel easy to the finding and calculation. Thank you from us.